Experiment 4. Aim 1. To observe the action of zinc, iron, copper and aluminium metals on the following salt solutions. A. ZnSO4 in aqueous state. B. FeSO4 in aqueous state. C. CuSO4 in aqueous state. D. Al2SO4 3 in aqueous state. 2. Arrange zinc, iron, copper and aluminium metals in the decreasing order of reactivity based on the above result. Materials required. Marker. A piece of sandpaper. 4 clean test tubes. A test tube stand. Copper sulfate solution. Aluminium sulfate solution. Zinc sulfate solution. Iron sulfate solution. Zinc, copper, iron, aluminium. Theory. Reactivity series. It is a metallic series in decreasing order of reactivity, also called electrochemical series. The more reactive metal displaces less reactive metal. Activity series of metals. K. Potassium. Ba. Barium. Ca. Calcium. Na. Sodium. Mg. Magnesium. Al. Aluminium. Zn. Zinc. Fe. Iron. Ni. Nickel. Sn. Tin. Pb. Lead. These metals are more reactive than hydrogen. H. Hydrogen. Cu. Copper. Hg. Mercury. Ag. Silver. Au. Gold. Pt. Platinum. These metals are less reactive than hydrogen. Metal salts are generally colored. Salts. ZnSO4. Original color. White salt. Color of aqueous solution. Colorless solution. FeSO4. Original color. Light green salt. Color of aqueous solution. Green solution. CuSO4. Original color. Blue salt. Color of aqueous solution. Blue solution. Al2SO4 3. Original color. White salt. Color of aqueous solution. Colorless solution. Reaction of metals with salt solution. 1. Salt solution, CuSO4. 2Al in solid state. Plus 3 CuSO4 in aqueous state. Results in Al2SO4 3 in aqueous state. Plus 3 Cu in solid state. Zn in solid state. Plus CuSO4 in aqueous state. Results in ZnSO4 in aqueous state. Plus Cu in solid state. Fe in solid state. Plus CuSO4 in aqueous state. Results in FeSO4 in aqueous state. Plus Cu in solid state. Cu in solid state. Plus CuSO4 in aqueous state. Results in no reaction. As aluminium, zinc and iron can displace copper from its salt solution, so all these are more reactive than copper. 2. Salt solution, FeSO4. 2Al in solid state. Plus 3 FeSO4 in aqueous state. Results in Al2SO4 3 in aqueous state. Plus 3 Fe in solid state. Zn in solid state. Plus FeSO4 in aqueous state. Results in ZnSO4 in aqueous state plus Fe in solid state. Fe in solid state plus FeSO4 in aqueous state results in no reaction. Cu in solid state plus FeSO4 in aqueous state results in no reaction. As zinc and aluminium can displace iron from its salt solution, so zinc and aluminium are highly reactive than iron, but copper is less reactive than iron. 3. Salt solution ZnSO4 2Al in solid state plus 3ZnSO4 in aqueous state results in Al2SO4 3 in aqueous state plus Zn in solid state. Zn in solid state plus ZnSO4 in aqueous state results in no reaction. Fe in solid state plus ZnSO4 in aqueous state results in no reaction. Cu in solid state plus ZnSO4 in aqueous state results in no reaction. 4. Salt solution Al2SO4 3 Zn in solid state plus Al2SO4 3 results in no reaction. Fe in solid state plus Al2SO4 3 results in no reaction. Cu in solid state plus Al2SO4 3 results in no reaction. Al in solid state plus Al2SO4 3 results in no reaction. As only aluminium metal displaces zinc from its salt solution, so aluminium is the most reactive metal among aluminium, zinc, iron and copper. The reactivity series order will be follows. Aluminium is more reactive than zinc, which is more reactive than iron, which is more reactive than copper. Procedure. Reaction with ZnSO4 solution. 1. Take 4 clean test tubes, label them as A, B, C and D respectively. 2. Add ZnSO4 solution in each test tube. 3. Dip small, clean pieces of aluminium, zinc, iron and copper metals in each test tube A, B, C and D respectively. 4. Record your observations. Metal solution ZnSO4 Test tube A Metal aluminium Experiment Al plus ZnSO4 Observation Deposition of Z in metal Inference Al is more reactive than Zn. Test tube B Metal zinc Experiment Zn plus ZnSO4 Observation No reaction Inference Equilibrium Test tube C Metal iron Experiment Fe plus ZnSO4 Observation No reaction Inference Iron is less reactive than zinc. Test tube D Metal copper Experiment Cu plus ZnSO4 Observation No reaction Inference Copper is less reactive than zinc. Conclusion Aluminium metal is more reactive than zinc. Reaction with CuSO4 solution 1. Take 4 clean test tubes. 2. Using a marker, label them as A, B, C and D. 3. Add copper sulfate solution in each test tubes. 4. Clean the pieces of aluminium, zinc, iron and copper metals by rubbing with sandpaper. 5. Dip a small, clean piece of aluminium, zinc, iron and copper metals in test tubes A, B, C and D, respectively. 6. Note your observations. Metal solution. CuSO4. Test tube A. Metal aluminium. Experiment. Al plus CuSO4. Observation. Blue solution turns colorless. Inference. Aluminium is more reactive than Cu. Test tube B. Metal zinc. Experiment. Zn plus CuSO4. Observation. Blue solution turns colorless. Inference. Zinc is more reactive than copper. Test tube C. Metal iron. Experiment. Fe plus CuSO4. Observation. Blue solution turns green. Inference. Iron is more reactive than copper. Test tube D. Metal copper. Experiment. Cu plus CuSO4. Observation. No change. Inference. Equilibrium. Conclusion. Above table shows that aluminium, zinc and iron metals are more reactive than copper. Therefore, copper is the least reactive metal among the given 4 metals. Reaction with FeSO4 solution. 1. Take 4 clean test tubes, label them as A, B, C and D respectively. 2. Add FeSO4 in aqueous state solution in each test tube. 3. Dip small, clean pieces of aluminium, zinc, iron and copper metals in each test tubes A, B, C and D respectively. 4. Note your observations. Metal solution. FeSO4. Test tube A. Metal aluminium. Experiment. Al plus FeSO4. Observation. Green solution turns colorless. Inference. Aluminium is more reactive than iron. Test tube B. Metal zinc. Experiment. Zn plus FeSO4. Observation. Green solution turns colorless. Inference. Zinc is more reactive than iron. Test tube C. Metal iron. Experiment. Fe plus FeSO4. Observation. No change. Inference. Equilibrium. Test tube D. Metal copper. Experiment. Cu plus FeSO4. Observation. No change. Inference. Copper is less reactive than iron. Conclusion. Aluminium and zinc metals are more reactive than iron and copper. Reaction with Al2SO4 3 solution. 1. Take 4 clean test tubes, label them as A, B, C and D respectively. 2. Add Al2SO4 3 solution in each test tube. 3. Dip small, clean pieces of aluminium, zinc, iron and copper metals in test tubes A, B, C and D respectively. 4. Note your observations. Metal solution. Al2SO4 3. Test tube A. Metal aluminium. Experiment. Al plus Al2SO4 3. Observation. No reaction. Inference. Equilibrium. Test tube B. Metal zinc. Experiment. Zn plus Al2, SO4, 3. Observation. No reaction. Inference. Zn is less reactive than Al. Test tube C. Metal iron. Experiment. Fe plus Al2, SO4, 3. Observation. No reaction. Inference. Iron is less reactive than aluminium. Test tube D. Metal copper. Experiment. Cu plus Al2, SO4, 3. Observation. No reaction. Inference. Copper is less reactive than aluminium. Conclusion. Aluminium metal is not displaced by any of the given metals, that is aluminium, zinc, iron, and copper. Therefore, aluminium metal is the most reactive metal among the given metals. 1. Aluminium is not displaced by any of the four metals from its salt solution, so aluminium remains at the top of the reactivity series. 2. Aluminium can displace zinc from its salt solution, but no other metal could displace it. Hence, the reactivity order is aluminium is more reactive than zinc. 3. Aluminium and zinc metals can displace iron metal from its salt solution, but copper cannot. Hence, the arrangement of metals in decreasing order reactivity series is: aluminium is more reactive than zinc, which is more reactive than iron, which is more reactive than copper. Precautionary measures. Clean the metals by rubbing them with a piece of sandpaper before dipping them in the salt solutions. Wash the test tubes after every set of observations of interaction of a particular metal with the four salt solutions. Use very little amount of saturated solution of copper sulfate, aluminium sulfate, iron sulfate, and zinc sulfate. Use very small pieces of metal every time. Do not touch any chemical with bare hands.